In previous class, the topic organic compound containing oxygen part 1 was completed. In that topic, we have three subtopics. One is alcohols, then phenols, and one more is ethers. From the point of board examination, we have totally 7-mark question from that topic. 3 to 4 marks from, as already told, from the alcohols, then around 2 marks from the topic phenols, and 1 or 2 marks from the ethers. So that's from the point of board exam. But for the competitive examination, we have at least 1 or 2 questions from the topic alcohols, phenols, and ethers. So for competitive examination, you must be perfect in all the portion as compared to that of the board examination. Now, today we are to discuss on the topic organic compound containing oxygen 2. It is not 2 oxygen, oxygen 2 means part 2. So here we are to discuss about aldehydes, ketones, and carboxylic acid. Well, in case of alcohols, phenols, and ether, the structure of alcohols, phenols, and ether is similar to that of the water. They have a bend shape like water. We know for alcohol it is ROH. For phenol, R may be phenyl, that is AR. And for ether it is RO. R dash. So here shape is similar to that of the water and oxygen is sp3 hybridized in all these cases. Well, in the aldehydes, ketones, and carboxylic acid, we have a common group. Like here we have a common shape like water. We have a common group for aldehydes, ketones, and it's carboxylic acid. Aldehyde are C double bond OH. Ketones are C double bond O, R dash or R. And carboxylic acid are C double bond O, then OH. So this is common. Which one? Carbonyl group is common for aldehydes, ketones, and carboxylic acid. And many of the preparations, the method of preparation and also properties, many of the properties and method of preparations of aldehydes and ketones are of the same type. So together you are studying aldehydes and ketones. Then carboxylic is a little bit different, but we have a carbonyl group, so all they are together we are studying in the organic compound containing oxygen. Let's discuss about aldehydes and ketones. Well, we know it's a carbonyl compound and carbon atom is sp2 hybridized. Valency of carbon is 4, that means we have 2 more valency. In nitrogen, these valencies may be satisfied by 2 hydrogen atoms. In aldehydes, 2 hydrogen atoms. Or it may be one of these is satisfied by the hydrocarbon group. Well, so you are representing aldehyde as RC double bond OH or RCHO, where R may be hydrogen or some other hydrocarbon. If it is hydrogen, then we have only one is there, it is formaldehyde. For remaining aldehydes, R is hydrocarbon group, not hydrogen. Second, ketones. Well, in ketone also we have C double bond O or carbonyl group. In ketone, the remaining 2 valency of carbon of the carbonyl group is satisfied by hydrocarbon. It may be aliphatic or aromatic. Both may be aromatic, both may be aliphatic, both may be again, one may be aliphatic, another may be aromatic. Maybe it's substituted aromatic or substituted aliphatic hydrocarbon group. Well, let us discuss on the topic is aldehydes and ketones. Aldehydes and ketones. Aldehydes and ketones. So both are carbonyl compounds, aldehyde and ketones. Okay. Both are carbonyl compounds. Both means aldehyde and ketones. Both are carbonyl compounds. Well, in aldehyde, the two valency of carbon of the carbonyl group may be satisfied by two hydrogen atoms or one nitrogen atom and another is organic group or hydrocarbon group. Both are carbonyl compounds, so we may write this like this: C=O dash. In aldehydes, valency of two valency of carbon atom, valency of carbon atom of carbonyl group is satisfied by two hydrogen atoms or one nitrogen and another carbonyl group, and another by carbonyl group. I'm sorry, by hydrocarbon group. By hydrocarbon group. Hydrocarbon group. They are represented by general formula RCHO or RCOOH. Hello. ಸರ್ ಸ್ವಲ್ಪ ಬಿಸಿ ಇದೆ, ನಾವೇ ಮಾಡಲಿ ನಮ್ಮ ಬಂದು ಸರ್. ಒಂದು ಅರ್ಧ ತಾಸು ಸರ್, ನಾನೇ ಮಾಡ್ತೇನೆ. ಓಕೆ, ಇದೇ ನಂಬರ್ ಅಲ್ಲ? ಸ್ಟಾರ್ಟ್ ಉಂಟಾ? ಸೊ RCHO or RC=OH, where R may be hydrogen or alkyl or aryl or maybe substituted group. In ketones, two valency of carbonyl group of carbon, two valency of carbon of carbonyl group is satisfied by alkyl or aryl group. They are represented by represented by general formula RC where R may be equal to R dash or R may not be equal to R dash, and it may be alkyl or aryl. Both may be equal or both may be different. Both may be aryl, both may be alkyl, or both alkyl may be identical. Both aryl may be identical. So this is the definition for aldehydes and ketones. Now let us discuss about nomenclature. As we know, organic compounds are named by two methods. One is a common and another is IUPAC system. For aldehydes, in common system, it's derived from the carboxylic acid. The oic acid of the carboxylic is replaced by aldehyde. For example, formic acid. Ic acid is replaced by what? Aldehyde. So, formaldehyde. Acetic acid, acetaldehyde. Propionic acid, propionaldehyde. Benzoic acid, benzaldehyde. So, this is the common system. And in IUPAC system, we know the suffix for aldehyde are Al. It depends on the number of carbon atoms. If you have one carbon, methane is replaced by R, methanol. Ethane is replaced by R, ethanol. Propane, butane, etc. And in IUPAC system, again we know the numbering is important from the carbon which is close to the aldehydic group, or actually it starts from the aldehydic carbon only, that you are studied even in the PUC first year class. Okay, let us discuss about nomenclature of aldehydes and ketones. Nomenclature of aldehydes and ketones. Of aldehydes. Said common name or in common system, this name is derived from carboxylic acid. Carboxylic acid is obtained by replacing ic acid or oic acid by aldehyde. So examples. First member of aldehyde is HCHO. So the corresponding carboxylic acid is HCOOH. It's called formic acid. Ic acid is replaced by aldehyde. So name of this compound is formaldehyde. CHO is the functional group of aldehyde. Remember this one. Formaldehyde. Then CH3CHO corresponding acid is acetic acid. So acetaldehyde. Then we have CH3, CH, Br, CH. So in case of common system, you are not numbering 1, 2, 3. Instead of 1, 2, 3, you are using Greek alphabet, alpha, beta, gamma, delta, and so. So here alpha means adjacent to the functional group. So after functional group, next carbon is alpha, then beta, gamma, delta, and so. So here on the alpha carbon we have Br. So this one is alpha bromo. Alpha bromo. Number of carbon atom are 3. So it's propionic acid. And aldehyde is alpha bromo propion aldehyde. Propion aldehyde. Then we have, I am writing one more, it is benzoic acid, derived from benzoic acid, CHO aldehyde. So it is benzaldehyde. Benzaldehyde. So in this way, we can name the organic compound, the aldehyde by common system. Then we have IUPAC system. IUPAC system. So we know important point in IUPAC system is suffix. Suffix for aldehyde is R and numbering the carbon from the end of the carbonyl or aldehyde group. Then you have to see the substituent on which carbon we have substituted. From that you have to start 1, 2, 3 and so on. Well, so in case of IUPAC, suffix is R and afterwards usual rule. And also when we have the aldehyde group attached to the ring, then they are called, it may be cyclohexane ring or aromatic ring. Then CHO group is named as carbaldehyde. If CHO group is attached to cycloalkane, or you may say simple cyclic compound, cyclic hydrocarbon, then CHO group is named as carbaldehyde. So examples for this. Examples is, I am writing this only first one, HCHO. Also suffix Al. How many carbon are there? 1. That means methane is replaced by R. It is methanol. Then we have CH3CHO. You can write any example. CH3CHO. How many carbon? 2. So it is ethanol. Then CH3, CHBr, then it is CHO. So how many carbon? We have 3 carbon and one substituent or prefix is there that number the carbon from the end of the CHO. So from this end it is 1, 2, 3. So this one is 2 bromo with propanol is replaced by R. What about this one? So IUPAC name of this one is benzene carbaldehyde. is not replaced by R or is not replaced by this carboxylic is retained. It may be aromatic ring or it may be this cyclic, aliphatic cyclic. Then here is not replaced by R. It is called carboxylic, benzene carboxylic, benzene carboxylic. Even this name benzaldehyde is also included by IUPAC. Benzaldehyde. This name is also included in IUPAC system. Both name you can name this one as a benzene carboxylic or it can also be named as benzaldehyde. Now I am writing some examples for the aldehydes. We know you have to write the structure and afterwards writing the common name and IUPAC name. Well, I am making 3 columns. In first column writing the formula, then sub common name, and IUPAC name. Formula, common name and IUPAC name. So already as given HCHO and CH3 CHO, I am writing different examples. It is CH3 CH2 CHO3 CHO. First I am writing simple example CH2CHO. Then CH3 CH2 CHO3 CH. Afterwards, we can write few more examples like CHO. Then we can write like this: CH double bond CHO. Then we can write the one more example, so CHO. Well, the name of first compound is, common name is methylprobute. So the corresponding acid is butyric acid. U is replaced by aldehyde. So it is a butyraldehyde according to the common system. Butyric acid is replaced by aldehyde. So it is butyraldehyde. It is replaced by aldehyde. Afterwards, again, it's a derivative of butyraldehyde. Totally 4 carbon, butyric acid, butyraldehyde. On the second carbon, it is a OCH3. And we know the second carbon is called alpha according to common system. And by IUPAC, it is a second number 2, 3, 4. Alpha means adjacent to the CHO. So the name of this compound is alpha. Already we have studied ether. It's ether. OCH3 is ether, alkoxy. Which alkoxy? Methoxy. CH3 means methoxy. So alpha methoxy, butyraldehyde. Then what about this? So I told, when we have the aromatic or cyclic compound and CHO, that aromatic or cyclic group is named first, is not replaced, it is retained, and afterwards this one is named as carboxylic. There is no common name for this compound. Well, this one is called cinnamaldehyde. and there is no common name for next compound also. So it's there, Aldehyde. Aldehyde for this one, because aromatically we have phthalic acid, Aldehyde. Well, now writing the IUPAC. In IUPAC system, so 1, 2, 3, 4, butane is replaced by R. That means butanol. Butanol, B-U-T-A-N-A. So butanol, no need to write butanol 1R. Why no need? This is because it implies that CHO group is on first carbon itself. Because you are starting, you are numbering from the end of the, from the CHO group itself. Well, next one, on the second carbon we have OCH3, so it is 2-methoxy. 2-methoxy, then butanol. No need to write 1R. Well, we know this is cyclohexane. 6 carbon are there, cyclohexane. If you have 5 carbon, then cyclopentane. This ring has 6 carbons, so it is cyclohexane. And this one is called carboxylic. Simple, it's a cyclohexane carboxylic. Cyclohexane carboxylic. Cyclohexane carboxylic. But this is called cinematic. Now, how to name this one? Well, here we know always you have to start from the CHO. Number from the CHO. So, first carbon, second, and third. You have substituent on the third carbon, that is a benzene ring, and we know benzene ring is called phenyl. C6H4 is called phenyl. Well, so it is 3-phenyl. 3-phenyl. Next one, how many carbon we have? Totally 3. 3 means with prop. So 3-phenyl, prop, 2-phenol. Prop 2 in, write if you want, 1R. No need to specify this one, it implies it's on the first carbon itself, but on the second carbon we have a double bond. So it is 2 in, may or may not write 1, but all is necessary. Well, afterwards this one, number the carbon, not from this carbon, CHO, whenever we have the ring or aromatic ring or simple non-aromatic ring, what you have to see? You have to see the CHO, how many groups are there, and that carbon is not counted. So here you have to count the carbon from here 1, 2, 3 and so on. So it's benzene 1, 2, how many CHO are there? 2, dicarbonyldehyde. So it's benzene 1, 2, dicarbonyldehyde. You may write any example, any aldehyde, and just you have to remember numbering. IUPAC system is important. Numbering the carbon, and afterwards you have to see what type of substituent is there. So prefix for the substituent. Just you have to remember already that you are studied in UC first year. It's simple. Even many cases without the nomenclature, we used to start the preparation and properties of compounds. But some idea is needed for this nomenclature. Now let us discuss about the nomenclature of ketones. These are methods. We have 2 methods.